Okay, on this video, we're going to look at graphing secant and cosecant functions here. Let's start off with cosecant, and let's look at the basic one here. So we're going to do cosecant of x. Now, the way I'm going to do cosecant is I'm going to sketch here the sine function first. So we ought to know that there's a relationship between cosecant and sine. They are reciprocals of each other. So what I'm going to do first here is draw the graph of sine. So let's notice here that cosecant and sine are related, so the period would be 2 pi. And so we're going to go all the way out to 2 pi. That means we would be counting by pi over 2's. So it would be pi over 2, pi, 3 pi over 2, and then 2 pi. Of course, when we change our row variable, those count bys would change and the period would change. Now, so if I have just a sine function, remember it's going to bounce back and forth between -1 and 1. So the sine starts at 0 and goes up here. So it started at 0, then it would go up to 1, back down to 0, down to -1, and then back to 0. Now, I'm just going to dot this in kind of real lightly here. And so that's my basic sine curve. Now, to get cosecant, what I'm going to think about is this question. Where is sine x 0? Okay? And so let's notice on the graph where the sine is 0. So that would be at 0, it would be at pi, and then it would be at 2 pi. Now, think of this idea. What about cosecant then? So cosecant is equal to 1 over sine. And if sine was 0, it would be 1 over 0. So where sine is 0, cosecant is undefined. Let me write that down. Where sine x is 0, cosecant x is undefined. Okay, and so that should make sense to us because cosecant is 1 over sine. Now, so where sine is 0 on my graph, the ones I just dotted in there, 0, pi, and 2 pi, that is where cosecant is going to be undefined. So at those values, I'm going to have asymptotes. So I'm going to draw asymptote at 0, an asymptote at pi, and then an asymptote at 2 pi. Now, I'm finally going to graph cosecant. So what I'm going to do is I'm going to take the min and max points and just chase the asymptotes with curves. Now keep in mind the curves cannot cross into the sine curve. So we've got a maximum point here. So we're going to chase the curves, or the curves will chase those lines upwards like that, sort of like a parabola. And then down here, we chase the curves or chase the lines this way. The curves would chase the lines downward. And so now I can go back and now erase the sine part. And now I've got the graph of cosecant x. So anytime I graph cosecant x, I start off with sine. If I can graph sine, then graphing cosecant is not that much more of a step. Now, let's graph secant. So let's do y equals the secant of x. So what I'm going to think about here is the cosine graph. So we'll sketch the graph of cosine. Keep in mind the period would still be just 2 pi because I don't have a row variable. And so we count by pi over 2. So we have pi over 2, pi, 3 pi over 2, and then finally 2 pi. Okay, so it's going to cosine's going to bounce back and forth between 1 and -1. So let's remember what cosine does. Cosine starts at 1 and then goes down. So the 1, and then pi over 2, and then pi, 3 pi over 2, back up to 1. So we'll dot this in. Okay, so there's our cosine curve. Now, we're going to graph secant from this. Now, we're going to ask this question about cosine, just like we did sine. Where is cosine x? 0. So let's answer that. Where is the cosine at 0 here? So that would be at pi over 2, and then it would be at 3 pi over 2. Now, let's look at this idea. Where cosine is 0, see if you can figure this out. Where cosine of x is 0, what is that going to mean about secant? So where cosine x is 0, y equals secant x would be undefined. So it's very, very similar to the last graph. So wherever my cosine curve is crossing the x-axis is where my asymptotes will be for my secant graph. So now I'm going to draw in my asymptotes there. Okay, now it's just very similar to cosecant. I'm going to look at the max points and chase here. All right, got a minimum point down here. So they're going to chase downward. And so the max points chase up, the min points chase down because you don't cross into the cosine curve. And see this one over here would chase up this way. Now I'm going to erase my cosine curve. And now I've got my secant graph. So notice secant doesn't look as nice because you get this half and then this half. You don't really get the full curves. You only get half of the curves when you only do just one cycle there. Now, let's look at some where we put in some values here, especially with an amplitude. Okay, so what we're actually going to do is I'm going to try this one from our software here. All right, so notice this one's got y equals -5 cosecant x. All right, let's take this one and let's see if we can graph that. Y equals, darn, I forgot what it was. All right, -5 cosecant x. Okay, now, so what I'm going to think about to graph -5 cosecant x is I'm going to think of the graph of y equals -5 sine x. And I'm going to graph that one. And so I'm going to dot that one in, and if I can do -5 sine x, then I can do -5 cosecant x. All right, so let's start off. Notice we don't have right there, you don't have a row variable, you don't have a coefficient in front of x, so the period is going to be 2 pi, so it's going to be counting by pi over 2 here. Pi over 2, pi, 3 pi over 2, and then 2 pi. Now, so what's changed here from probably our previous graphs is now we have an amplitude. Okay, so instead of bouncing back and forth between 1 and -1, this one's going to go further up. It's going to bounce in between 5 and -5. Okay, I'm going to need to move this down to make sure my secant graph or my cosecant graph doesn't mess with anything. Okay. Now, So let's sketch in -5 sine x. Now sine starts at 0 and goes up, but it's -5, so it'll start at 0 and actually go down. So it'll go 0, and then at pi over 2, it'll go down to -5, and then back up to pi, up to +5, and then down to 0 at 2 pi. So again, this is just the sine curve. Okay, now we're ready to do cosecant. So where sine is 0, cosecant will be undefined. So my 0 marks here, 0, pi, and 2 pi, and we're going to have some asymptotes. Now, all we have to do to get cosecant is start from those min and max points there and chase the asymptotes. Okay, now I'm going to go back and erase my sine. Okay, so now I have my graph for cosecant. Now, let's look and let's see if we can pick the right one from a homework problem here. Okay, so notice the undefined spots, right? 0, pi, and 2 pi. A lot of that is what's going to give away here which one's right. Okay, so let's see. All right, notice first that the amplitude was 5. So if you notice this graph, that says 2 there. And so they're showing an amplitude basically of 1 and -1. So that certainly is not going to work. And so this one, C, has the same thing. Okay, now let's notice the difference between B and D. Again, where we were undefined at, those dotted lines, was at pi and, or 0 and pi and 2 pi. We got 0, pi, 2 pi. That seems to be okay. Now over here you got 0 and then pi and 2 pi. Okay, so that's the same. So what's different here is the first curve that we've got, that one's going up, and then this one's going down. So let's see which one our first one looked like, because I forgot. All right, notice our first one there was going downward. So it should be the one that's going downwards here. Okay, so the one that was going downwards and had the correct amplitude of 5 there and there should be D. Okay, now let's look at the same old questions that they just keep asking me here. Domain and range. All right, so let's notice the graph here, and let me pull it up. Okay, so let's just think, where was it undefined at? Okay, so it was undefined there at, we had it at 0, and then at pi, and then at 2 pi. So if you notice that 0, pi, and 2 pi, that would just be multiples of pi. So those are the places where it could not be undefined. So let's see if we can tell which one we're going to have here. So which one is telling me the multiples of pi? So that would be B there. Just need to close that. Okay, now the next part, of course, it's going to ask me for the range. Now, here again, let's look at the graph. Okay, so let's picture the range with this. So you remember the range, what I'm going to do is go from the top to the bottom. Okay, so I would just scan here, trying to draw a line, but that doesn't seem to be working out. Scan it from the top to the bottom. So notice we've got stuff here in this part of the graph covered, and then we have stuff here. But in the middle, let's notice in this area, okay, there's nothing in between here. All right, we did have a sine curve, but that's really not a part of the graph. That was just to help me graph cosecant. So there's nothing in between those two values. So remember, this was -5 and this was +5. So it's everything but what's in between -5 and +5 now. All right, so let's remember that. Let's see if we can pick the right answer. So we're looking now for everything that would be everything but what's in between. So let's think about it. That would be stuff that would be less than, so this was -5, that was +5. So everything that was less than -5, but then greater than +5. And so this is going to be C there. Okay, now if you were maybe thinking about this choice, values what y less than, I'm sorry, greater than -5 and less than or equal to -5, well, that's this part. That's the part that it's actually not. We're looking for the part that that graph actually exists. So that should be C there. Okay, now let's look at a similar one. All right, that's really not that much different. So it's got 2 times cosecant. I was trying to think of one here that would be secant, so we could get a little bit of variation. Let me see. Okay, now I'm going to do an example with secant. Now, I couldn't get a secant one to sort of come up in the homework. I kept trying to do similar examples, but it wouldn't come up. I think we need to look at one just in case that they pop one on the quiz. So let's try this one. Let's do y equals, let's say we have -3 secant of x. Okay, so what I'm going to do here to graph secant is first we're going to think about this graph. We're going to graph first here y equals -3 cosine x. So let's dot in this graph. All right, so notice they're not really changing the period up on us. They're not giving us any row variables, so coefficients that are in front of x, pi, and then 3 pi over 2, and then 2 pi. So let's think about how we would do -3 cosine x there. So my amplitude is 3. It's going to go up to 3 and then down to -3. Now, cosine, normally we say the graph starts up at 1 and goes down. In this case, it's negative though. So instead of starting at the high point and going down, it's going to start at the low point and go up. So it's going to start down at -3. So go -3, and then up to pi over 2, then up to 3 at pi, back down to 0 at 3 pi over 2, and then back down to -3. So I'm going to dot this in. Okay, now let's actually do secant. So secant is going to be undefined where cosine is 0. So from our graph, cosine is 0 at pi over 2 and 3 pi over 2. So I'm going to draw in some asymptotes there. And now we're just going to chase those curves from our max and min points here. So from -3, I'm going to chase that line downward. All right, this curve's going to chase those two asymptotes upwards. And then, oh, sorry, down here, it's going to chase that one downward. And I'm going to go back and Erase my cosine curve. Okay, so now there's my secant graph. Now let's look here at the domain and the range. Okay, so domain, all right, let's notice where it's undefined here. It's undefined at pi over 2 and 3 pi over 2. So the way I would describe it here is we're looking at the odd integer multiples of pi over 2 is where it would be undefined. So I guess probably the way I should say that is what x cannot be. I'm going to write it probably the way that your answer choices would say. So probably say for all x such that x cannot equal k times pi over 2, where k is an odd integer. Okay, now for my range, all right, let's notice what the range is. So basically, the range is sort of everything except for what's in between here, between -3 and 3. So I didn't have any graph in this area. It was all either above 3 or under -3. So let's write this idea out here. So my values for should be y because it's range. So for all y such that, all right, think about the values that are under -3 and how I could write that. So that would be y would be less than or equal to -3. And then the values above +3, I could write or y would be greater than or equal to +3. Now certainly if I had the choice on how I had to write the range there, I would probably write that in interval notation. That would be easier for me to think about. That would just be -infinity to -3 and then 3 to infinity. But they're not going to write it that way. They're going to write it with that set notation. Okay, there's your graphs now for secant and cosecant. That's only one question that you're going to have on the homework on that. That's it.